Hello guys, in this video we'll be solving question based on initial value and final value theorem. Okay, so let us see the question. Find the initial and final value of x of z. This is a function given x of z. We need to find the initial and final value. So before that, we need to understand what is initial value theorem and final value theorem. You might have studied the proof of that, so we have to just see the result in order to solve the questions. So here, if x of n z transform, if you are finding, that will be x of z. Here small n, capital L, small x, capital X. Okay, there is a difference. So if I apply limit n tends to 0 for this function, it will be x of n, that will be x of 0. See, n tends to 0, this will be x of 0. So the x of 0 is given, and this is the important first thing. Okay, so that is given by x of 0 is equal to limit z tends to infinite x of z. This x of z will be given in the question. We have to just apply limit for that z tends to infinite in order to get the initial value. This is the initial value. Okay, now for the final value, you have to see the final value theorem. Again, the same thing. For this function, we are applying limit n tends to infinite. There it was 0 for initial value, here it is infinite. You have to apply. So x of n, if I apply n tends to infinite, this will be x of infinite. Okay, there it was x of 0. So x of infinite, this is the second important equation. So x of infinite is limit z tends to 1. Here it is z tends to 1. Z minus 1, this is the extra thing, into x of z. So this will be given in the question. So we need to find x of infinite. These two things we need to find. Okay, so let us see the x of z value here. So here it is 1 by 1 plus 2 z power minus 1 minus 3 into z power minus 2. This all are in negative powers. Okay, so first we'll find out x of 0. How will you find out x of 0? Simple thing, again the same thing, limit z tends to infinite x of z. Simply you have to put the value of x of z, and you have to just apply the limits to the function. Okay, so limit z tends to infinite, this will be x of z value is given as 1 by 1 plus 2 power minus 1, or 2 into z power minus 1 minus 3 into z power minus 2. Okay, so one more thing you need to remember, in initial value, while you are finding out, when you substitute the value of x of z, always remember the z power should be negative. Always remember this. Okay, for x of 0 initial value, when you are finding out, because since this is limit z tends to infinite, that's why the powers of z should be negative. Okay, always remember. For the final thing, I'll just come to that. So first we'll just solve this. So always remember the power should be negative, or in other words, z power minus 1, or you can write it as 1 by z. It should be in this form, z power minus 2 1 by z power 2, like that. Okay, so limit z tends to infinite. So I'll just write it in a better way, 1 plus 2 by z. Yes, I can write z power minus 1 is 1 by z, so 2 by z minus 3 by z power 2. Correct, it's the same thing. Now when I put the limit, when I apply the limit to this function, so what it will be? So limit, so I'll apply to this function. So 1 by 1 plus 2 by infinite, correct, 2 by infinite minus 3 by infinite square. So as we know, 1 by infinite will be what? 0. So this will be 1 by 1 plus 0 minus 0. So 1 by 1, which is equal to 1. So this will be the final answer. So 1 by infinite square will be infinite only. Okay, so 1 by infinite will be 0. So final answer will be 1. So let us now find out the final value. Now for the final value, again the same thing what we have studied. The x of infinite we have to find out. We have to apply limit z tends to 1, z minus 1, x of z. X of z is given, so let us see that. So x of infinite for the final value, which is equal to limit z tends to 1, z minus 1, you have to multiply x of z. Correct. So here always remember, when you substitute the x of z here, it should be positive powers. This thing you have to remember. There it was negative powers for the initial value, x of 0. Here x of infinite, the x of z value should be positive powers. That means it should be z power 2, z power 3, like that. Okay, this thing you have to remember. Now when I substitute here, limit z tends to 1, z minus 1 into x of z value, I'll substitute here 1 by 1 plus 2 z power minus 1 minus 3 z power minus 2. As I said, the power should be positive, so I have to bring it in a positive powers. So what I can do, same thing, I'll write it here. Now here I can, okay, I'll write it in this form: 1 plus 2 by z minus 3 by z square. From this I can take LCM, right? LCM will be what? Z power 2, correct? So I can take LCM here. Limit z tends to 1, z minus 1. So taking LCM in the denominator part, so it will be z square plus 2z minus 3. Carefully you have to take the LCM, okay? Here it is z power 2, so z power 2 plus 2z minus 3 divided by z power 2 will be there, so this will go up, correct? Yes. So this will be what? Limit z tends to 1, z minus 1 into z square by, this will go up, so z square by z square plus 2z minus 3. So as you can see, now the powers are in the positive powers, correct? Now we can apply one more thing. The denominator is in what? Quadratic form, correct? So somehow we can cancel this z minus 1. How we can cancel this? If you find out this quadratic form, if you factorize this quadratic form, let me just show you that. In calci you can directly do it, okay? So go to mode, press 5 equation, then the third option, correct, quadratic form. You can give the coefficients 1, I hope you know how to do this, minus 3, yes, 1, 2, minus 3 coefficients. So press equal to, you will get 1 and minus 3, right? So z value is 1 and minus 3, so I can write this as what? See here carefully, so I'll write it here. So again, limit z tends to 1, z minus 1 is already there, z square by, I got z value as 1 and minus 3, so plus 1 means I have to write z minus 1, then minus 3 I got, that means z plus 3 I have to write, correct? Okay, this is a logic. Now as you can see, z minus 1 is here, here also z minus 1, these two get cancelled, numerator and denominator, yes. So what is remaining? Z square by z plus 1 is z plus 3 is remaining, so I can directly apply now what? Z tends to 1, apply to this function, so answer will be what? So 1 square by 1 plus 3, simple. So this will be 1 by 1 plus 3 is 4. So the x of infinite value is what? The final value of this function is given as 1 by 4, correct?